Welcome to another one of our lessons in our chemistry lecture series. We are on the topic of the mole concept. Now, we've looked so far at balancing equations. We've looked at calculating molar masses. We are now going to look at performing calculations that involves the mole and equation. So today's objective will be to perform calculation involving the mole and equation. So when we write our equation, we must ensure that it is balanced. And then we are going to use a particular quantity given in the question to find quantitatively the mass of another substance or volume of another substance in that same equation using the mole ratio that we get from the balanced equation. Let us start. In carrying out calculations involving the moles and equation, we can simply follow some simple steps. Now, these include balancing the equation. If you don't balance your equations correctly and put in your state symbols, you are going to have problems in getting the correct answer. So ensure that before you do any calculation involving the moles and equation, that you balance the equation. We are going to then convert any given substance in the question that can be mass or volume into moles. So given a particular substance, you might be given the mass, let's say 2 grams of sodium or 20 cm cube of HCl. We are going to use that information in the question and convert that quantity into moles. After which, we are going to use the balance equation and what was calculated for the moles of a substance and the stoichiometric ratio to find the moles of another substance that we need. After which, when we get the mole of that desired substance, we can then convert that substance into mass or volume. Let us see these steps in detail slowly so you can truly understand and appreciate what is going on. Here's our first example. Now, what mass of sodium hydroxide will be formed by 9.2 grams of sodium which reacted with water to produce sodium hydroxide and hydrogen gas? So again, let us pick out the most important things from this question. Now, we see here that we are concerned about the mass of sodium that is produced. But what mass will that be produced from? It will be produced from 9.2 grams of sodium. So right here, we have a particular quantity, which is mass of sodium. Now we are going to write our balance equation. Then we are going to convert this mass of sodium into moles. Then we'll use the mole ratio between sodium and sodium hydroxide to find the moles of sodium hydroxide, after which we will convert moles of sodium hydroxide into mass of sodium hydroxide. And that would conclude our question. Let's first start by balancing our equation. So, to balance this equation, we must first write the equation. So we write sodium solid plus water, which is liquid, produces sodium hydroxide. And this is aqueous plus hydrogen gas. So here we have sodium reacting with water to produce sodium hydroxide plus hydrogen gas. We're given 9.2 grams of sodium to produce sodium hydroxide, and we are concerned about the mass of sodium hydroxide produced. So let us balance our equation. But remember that balancing of an equation is a trial and error. So sometimes you will not get it on the first try. So here we have sodium, one sodium here. One oxygen atom, one oxygen atom here. 2 hydrogen and 1, 3. Over here we have 2. So we want to get a whole number. So we will put 2 here in front of water, which would make us have 4 on this side, on the left hand side of the equation. Over here we have 3. So if I put 2 here, I will now have 2 hydrogen and 2 there, 4. So since we changed some numbers, let's start over with the balancing process. So we now have 2 sodium atoms here, but 1 here, so we'll put 2 in front of the sodium. Let's check to see if our equation is balanced. 2 sodium, 2 sodium. 2 oxygen, 2 oxygen. 2 hydrogen plus 2, 4. 2 2's, 4 hydrogen atoms. So our equation is completely balanced. Now that we have our balanced equation, the next step is to convert the units of a given substance. In this case, it is 9.2 grams of sodium. So we're going to convert the units of the given substance in the question, which is sodium here. And we're going to convert this mass of sodium into moles of sodium. Now, we know the formula already to be moles equal mass over molar mass. So, what is the mass? The mass given in the question is 9.2 grams. And what is the molar mass of sodium? The molar mass of sodium is 23 grams per mole. So, what is our calculation? 9.2 divided by 23 is equal to 0.4 moles. So here we have 0.4 moles is present in 9.2 grams of sodium. We are now going to use the mole ratio, which is 2 to 2, where we're going to simplify it into a simplest whole number ratio. So 2 to 2 is the same thing as 1 to 1. So here we have sodium to sodium hydroxide is 2 to 2, which is 1 to 1. So the mole ratio between sodium and sodium hydroxide is 1 to 1. So since the mole ratio between sodium and sodium hydroxide in its simplest whole number ratio is 1 to 1, we are saying then that the moles of sodium hydroxide is also equal to 0.4 moles. Remember to always state the mole ratio when doing this type of problem in calculating the moles of one substance using the mole of another. So the moles of sodium hydroxide is also 0.4 moles. Why? Because the mole ratio between sodium and sodium hydroxide is 1 to 1. Now that we know the moles of sodium hydroxide, we can calculate the mass of sodium hydroxide from the moles of sodium hydroxide. So we will use mass equal moles times molar mass. So the moles here is 0.4 times the molar mass of sodium hydroxide, which we know how to calculate already, 23 plus 16 plus 1, which is equal to 40. So it is 0.4 mole times 40 grams per mole. Moles will cancel moles. And our answer here would now be 0.4 times 40 equals 16 grams. What is this value saying? This value is saying that 16 grams of sodium hydroxide will be produced if 9.2 grams of sodium reacted with water. So this is the answer for our problem. 16 grams of sodium hydroxide would have been produced from 9.2 grams of sodium. Let's try some others. Looking at this example, you would see that it is dealing with ionic compounds. In other words, ions would combine in solution to form a solid compound. Now the same rule would apply. So let's look at the question. If lead-2 ions were mixed with chloride ions, from excess hydrochloric acid, a white precipitate of lead-2 chloride would be formed out of solution. Calculate the mass of lead-2 chloride that would be formed if 5.0 grams of lead-2 ions were added to excess hydrochloric acid. Now here we have lead-2 ions. So the first thing we need to do is to write our balanced equation. So we'll write Pb 2+ for lead-2 ions. And all ions are aqueous in solution. Plus 2Cl minus, again, it is Aq for aqueous. And that forms lead-2 chloride. And this is your solid, which is your precipitate. Now we see that the equation here is balanced because I have one lead atom and one lead ion. Here I have 2 Cl atoms. Now I have 2 Cl ions. And my charges are balanced. Whenever you balance any equation, remember to ensure that you have both mass balance and charge balance. I cannot stress that enough. Now, what information do we have so that we can convert a particular mass into moles? Now, here we have 5 grams of lead-2 ions. So we have the mass of lead-2 ions. And from lead-2 ions, we want to know the mass of precipitate that will be formed. So let us calculate the moles of lead-2 ions. So moles is equal to mass over molar mass, which is 5 grams over the molar mass of lead-2 ions. If you check your periodic table, you would see that the molar mass of lead is 207 grams per mole. And now we're going to calculate the number of moles of lead-2+ ions present. So 5.0 divided by 207. And that is equal to 0.02. Let's keep it at 2 decimal places. So 0.02 moles. Now, as we can see, the mole ratio between lead-2 ions and lead-2 chloride is 1:1. So Pb 2+ to Pb Cl2 is 1:1. That means that the moles of Pb Cl2 is also equal to 0.02 moles. So basically, we use the moles of the substance reacting to find the moles of the substance being produced by simply using the mole ratio. After that, we are now going to convert our calculated moles into mass of lead-2 chloride. So we know that mass is equal to moles times molar mass. And our moles here is 0.02 moles times the molar mass of lead-2 chloride. So what is the molar mass of lead-2 chloride? Well, remember chlorine is 35.5, so it's 2 of them, so we must multiply that by 2, that is 71, plus lead, which is 207. And that should give you a molar mass of 207 278 grams per mole. So mole would cancel, mole, your answer is in grams. Then 0.02 times 278 is equal to 5.56 grams of lead 2 chloride. So 5.56 grams. So 5.56 grams of lead 2 chloride will be produced from 5 grams of lead 2 ions. So generally, we can work out any mass or volume given in a question from the quantity that is given in the question. All you need to do is to look at the question, see what is given, convert what is given into moles, then use the mole ratio between what is given and what is required to find the moles of the other substance. After you find the mole of that substance, you simply convert back that substance into mass or volume. Let's look at some general equations and have a quick discussion on how we would approach that type of question. Look at this question here. Suppose we are combining 2 grams of zinc with copper sulfate. So we are combining 2 grams of zinc with copper sulfate. The reaction will be zinc solid plus copper 2 sulfate produces zinc sulfate plus copper. We know that we're given 2 grams of zinc and we want to find the mass of zinc sulfate that will be produced when the reaction is complete. So, first thing to do again is to always balance the equation. So if you check this equation, you would see that it is balanced. We are then going to convert 2 grams of zinc into moles. After which, we're going to use the mole ratio between zinc and zinc sulfate. In this case, it is 1:1 to find the moles of zinc sulfate. And after we know the moles of zinc sulfate, we can find the mass of zinc sulfate from the moles of zinc sulfate. So, whatever the moles of zinc is from your calculation, the same mole will be for zinc sulfate because the mole ratio is 1:1. So it's not difficult. The same principle would apply when we're working with moles and molar volume. We would only use a different equation. So the equations we use for mass and equation, these include mole equal mass over molar mass and mass equal moles times molar mass. This concludes our lesson, and in our next topic, we will be looking at calculations involving the mole and molar volumes using equations. See you then.